Hello, happy holidays. Welcome to my session, Dashing Through the Cloud, courtesy of the amazing team at the Festive Tech Calendar. In this session, we will be dashing through the cloud to get familiar with fundamental cloud concepts, a high-level overview of Azure, followed by a brief introduction to Intune and Endpoint Management. To share about myself, I am Sucheta, a passionate IT tech and a manager in IT. I am certified in many Microsoft Azure areas. I am an Azure and Intune enthusiast. Have my Twitter handle noted here if you'd want to follow me for latest Azure, Intune, and Endpoint Management feed. While I have strived to cover the most important concepts pertaining to Azure in this session, this is only going to be an overview. Azure is pretty vast and the technology is evolving rapidly. So my content covers only the basics and the information is current as of Christmas 2022. I have also tried to design this session for anyone just beginning to work in the cloud to help them step into the cloud learning journey with ease. So let's get right in and start with understanding what cloud computing means. Cloud computing is the delivery of computing services over the internet. To put it differently, cloud computing is a way to rent and use resources and services from someone else's data center. And by someone else, here I mean renting from a cloud provider. For instance, you'll be using a PC that is in the cloud provider's data center instead of physically being with you. The cloud provider takes care of maintaining the underlying infrastructure for you. Cloud is intended as an over-the-internet delivery of IT resources. Resources such as compute, power, and storage. So what is compute? Compute pertains to software computation. You need compute power to be able to run a software application, for instance. Computing services include common IT infrastructure such as virtual machines, storage, databases, and networking. So circling back on cloud computing, typically you'd be renting resources and services like the ones I just mentioned from a cloud provider to run your software without building your own data center in most cases. That's the gist of cloud computing. Now let's learn about Azure. Azure is a cloud computing platform from Microsoft. So Microsoft is a cloud provider in this scenario. Azure is Microsoft's private secure network. It consists of several data centers together. Azure provides a wide array of ever-expanding cloud computing services where infrastructure management, scalability, availability, and security are mostly handled by Microsoft for you. Azure provides more than 100 services that enable you to do everything from running your existing applications on virtual machines, website and database hosting, to advanced computing services such as artificial intelligence, machine learning, and Internet of Things. With Azure, you can explore new software paradigms such as intelligent bots and mixed reality. Just like Azure from Microsoft, there are other competitive cloud computing platforms such as AWS, Amazon Web Services, and GCP, the Google Cloud Platform, to name a couple. Each cloud provider will have their own selection of services to choose from, but the basic services provided by all are compute, power, and storage. Now you would think, how does one leverage the cloud? Well, that is done by deploying your organization's workloads to the cloud, meaning switching the execution of your applications, services, or IT resources from on-prem to hosting them in the cloud. Many organizations start exploring the cloud by moving their existing applications to virtual machines that run in Azure. So why cloud and what are the benefits then? Now, among several benefits that cloud computing offers, I will introduce you to a few. Let's first briefly understand the two types of expenses to consider when comparing IT infrastructure models. These are capital expenditure, CapEx, and operational expenditure, OpEx. CapEx is a one-time expenditure to purchase tangible resources, such as building a data center, whereas OpEx is spending money on products and services over time. Signing up for cloud services is an example of OpEx. Now, why is using cloud services an example of OpEx? Well, because cloud customers only pay for the services and products or resources they use in the cloud. Cloud computing fundamentally operates on a consumption-based model, or a pay-as-you-go model, in other words. And that is one of the major benefits of using the cloud. Cloud providers enjoy economies of scale because resources are shared across organizations. This eventually translates to reduce the OpEx for cloud customers. In addition, cloud customers enjoy lower CapEx because they do not have to pay for costs associated with, like, building a data center. And that is because they rent resources from the cloud provider's data center. So with the consumption-based model, customers have no upfront costs, and they have the flexibility to pay more and use more resources when needed, while also stop paying for resources that they no longer need. Cloud computing can help meet variable demand. There are some other major benefits. The cloud provides high availability, or HA. HA focuses on ensuring maximum availability, ensuring resources are available when needed, regardless of disruptions. The cloud provides reliability, which is the ability of a system to recover from failures and continue to function. High availability and reliability work to keep applications always running. In the cloud, we can scale resources efficiently and effortlessly. Scalability basically refers to the ability to adjust resources to meet demand. You can quickly increase or decrease resources as needed. Also, because the cloud is a consumption-based model, when your resource demand drops, you have the ability to reduce the resources and thereby reduce your costs. Cloud features support governance and compliance. There are templates that help ensure that your deployed resources meet corporate standards and government regulatory requirements. Cloud-based auditing helps flag resources that are out of compliance with corporate standards. It also provides mitigation strategies. Cloud providers handle things like DDoS attacks, distributed denial of service attacks, making the network more robust and secure. And among some other prominent benefits, we have global reach of the cloud that is beneficial for organizations having a footprint across the globe. Also, the cloud enables faster innovation and flexibility because the delivery of resources and services is over the internet. Provisioning of resources in the cloud is fast. Virtual machines, servers, network, storage, databases, mostly everything can be stood up in clicks of buttons. There are three main cloud models: public, private, and hybrid. The models define the deployment type of cloud resources. Let's look at what the public cloud is. You'll see this model being leveraged by organizations the most. A public cloud is built, controlled, and maintained by a cloud provider, such as Microsoft in case of Azure. Anyone that wants to purchase cloud services can access and use resources, including individuals like you and me. Private cloud. It is mostly an evolution of a corporate data center. It is used by a single entity. Private cloud provides greater control to the consumer. However, it also comes with greater cost and fewer of the benefits of a public cloud deployment. This type of a model may be hosted from an organization's on-site data center or may be hosted in a dedicated data center off-site. It could also potentially be hosted by a third party that has a dedicated data center for this purpose. What would be the key difference between public and private cloud models? Well, it's the general public availability of the public cloud. Then we have hybrid. A hybrid cloud is a computing environment that uses both public and private clouds in an interconnected environment. Consumers can choose which services to keep in public cloud and which ones to deploy to their private cloud infrastructure. Lastly, there's also a multi-cloud scenario in which an organization uses multiple public cloud providers. Now looking at the shared responsibility model and some cloud service types. When it comes to the cloud, we have a shared responsibility model. With this model, responsibilities get shared between the cloud provider and the consumer. The shared responsibility model applies to the three different cloud service types shown here: IaaS, PaaS, and SaaS. The diagram highlights how the shared responsibility model informs who is responsible for what, depending on the cloud service type. It shows how the model applies to each cloud service type and to on-prem. I'll start with the on-prem infra. With an on-premises data center, you are responsible for everything. So if you look at the far right column in the diagram and refer to the legend at the bottom, you'll notice that all of the responsibilities such as information and data, devices, etc. are that of the customer. Now let's talk about the three cloud service types. Firstly, IaaS. IaaS is infrastructure as a service. It is the most flexible category as it provides maximum control for your cloud resources. A common IaaS scenario is where you have established configurations for development and test environments that you need to rapidly replicate. You can stand up or shut down such environments quickly with an IaaS structure. VMs provide infrastructure as a service or IaaS in the form of a virtualized server. In an IaaS model, the cloud provider is responsible for maintaining the physical infrastructure and its access to the internet. You're responsible for everything else: operating system installation, configuration, patching, network, database, and so on. With IaaS, it is more like renting the hardware in a cloud data center, and then you do what you need to with that hardware. Second one here is PaaS. PaaS is platform as a service. It is a middle ground between renting space in a data center, that is infrastructure as a service, and paying for a complete and deployed solution, that is software as a service. A common PaaS scenario is providing a framework that developers can build upon to develop or customize cloud-based applications. Thus, PaaS is suited to provide a complete development environment without the headache of maintaining development infrastructure. In a PaaS environment, the cloud provider is responsible for maintaining the physical infrastructure and its access to the internet, just like in IaaS. In addition, the provider will also maintain the operating systems, patching, middleware, databases, and development tools. Lastly, we have SaaS. SaaS, or software as a service, is a complete cloud service model from a product standpoint. With SaaS, you're essentially renting or using a fully developed application. A common SaaS implementation example is a productivity application such as Office 365. The SaaS model is the least flexible, but at the same time, it is the easiest to implement, with not much of technical expertise required. With SaaS, you're responsible for the data you put into the system, the devices you allow to connect, and the users that have access. Everything else mostly falls to the cloud provider. Now, the core architectural components of Azure can be broken down into the physical infrastructure and the management infrastructure. Let's look at Azure physical infrastructure. It starts with data centers. Azure has data centers around the world. Azure's regional data centers allow you to distribute apps locally, so you can locate your data and apps where it is needed most, thereby improving application performance. A region is a geographical area that contains one or more multiple data centers that are networked together. When you deploy a resource in Azure, you choose the region where you want the resource deployed. Then we have availability zones, which are physically separate data centers within a region. Each availability zone is made up of one or more data centers that have independent power, cooling, and networking. So if one zone goes down, the other continues to work, thus ensuring that your services and data are redundant and you protect your information in case of failure. Azure helps make your app highly available through availability zones by leveraging the zones for multiple VMs, SQL databases, etc. Lastly, we have region pairs. Azure regions are paired with another region within the same geography, at least 300 miles away. This helps to replicate resources and reduce the likelihood of interruptions because of events such as power outages, natural disasters, etc. In such cases, services would automatically fail over to the other region in its region pair. An example of region pair is West US paired with East US. Then switching to the Azure management infrastructure. You can see from the diagram that it includes a hierarchy of Azure resources, resource groups, subscriptions, and accounts. A resource is the basic building block here. In Azure, anything you create, provision, or deploy is a resource. Few examples are virtual machines, virtual networks, databases. Resource groups group resources together. When you create a resource, you must place it into a resource group. A resource group can contain many resources, but a single resource can only be in one resource group at a given time. Actions applied to a resource group apply to all the resources within the resource group. This includes deletion and granting or denying access. Subscriptions. The way resource group logically organizes resources, subscriptions logically organize resource groups. They are a unit of billing, management, and scale. You can use subscriptions to define boundaries around Azure products, services, and resources. An Azure subscription links to an Azure account. which is an identity in Azure Active Directory or Azure AD or AAD. An account can have multiple subscriptions. What are management groups? Now, when you have many subscriptions, you need to efficiently manage access, policies, and compliance for all those subscriptions, and management groups facilitate that by providing a level of scope above subscriptions. Moving further to Azure services. I will now briefly touch upon some of the most important Azure services such as compute, networking, and storage. Azure VMs are a popular compute service offering from Azure. You can create and use VMs in the cloud. To scale VMs in Azure, you can leverage virtual machine scale sets, which lets you create and manage a group of identical load-balanced VMs in an automated way. Then we have virtual machine availability sets, which are designed to ensure that VMs stagger updates and have varied power and network connectivity, preventing you from losing all your VMs with a single network or power failure. This is achieved by grouping VMs in two ways: update domain and fault domain. Azure containers. For running multiple instances of an application on a single host machine, containers can be used. They are a virtualization environment. Azure Container Instances and Azure Kubernetes Service allows you to deploy containerized applications with fully managed services. Then we have Azure Functions. With Azure Functions, you can create event-driven serverless applications with no coding required. Lastly, Azure App Service. Apart from VMs and containers, there are other hosting options that you can use with Azure, like the Azure App Service, which enables you to build and host web apps and RESTful APIs without managing infrastructure. Talking about networking, we have Azure Virtual Networks. Virtual networks and virtual subnets enable Azure resources such as VMs and databases to communicate with each other, with users on the internet, and with on-premises computers. You can link virtual networks together by using virtual network peering. Azure Express Route. It lets you extend on-premises networks into cloud over a private connection. Azure DNS. It is a hosting service for DNS domains that provides name resolution by using Azure infrastructure. Talking about storage, Azure provides cloud-based storage. You need to create Azure storage accounts for any kind of storage that you would need. Such an account provides a unique namespace for your Azure storage data. The data will be accessible from anywhere in the world over HTTP or HTTPS. Data in this account is secure, highly available, durable, and massively scalable. While creating a storage account, you pick the storage account type, which determines the services and redundancy options. There are various redundancy options available to ensure that the storage account meets availability and durability targets, even in case of failures. To name a couple, we have locally redundant storage or LRS, geo-redundant storage or GRS, and so on. The Azure Storage Platform includes some data services. Azure Blobs. It is a scalable object store for text and binary data. Then we have Azure Files, which are managed file shares for cloud and on-premises deployments. Azure Queues is a messaging store for reliable messaging between application components. Azure Disks are block-level storage volumes for Azure VMs. Now talking about Azure Identity, Access, and Security. Let's start with Azure AD or AAD, Azure Active Directory. It is a directory service that enables you to sign in and access both cloud applications from Microsoft as well as the ones you develop. On-prem Active Directory can be connected and synced with Azure AD using Azure AD Connect. On the security side, Azure Active Directory uses conditional access to allow or deny access to resources based on identity signals. These signals include who the user is, where the user is, and what device the user is requesting access from. Azure RBAC. RBAC is role-based access control. Instead of defining the detailed access requirements for each individual, you can control access through Azure role-based access control. Azure provides built-in roles that describe common access rules for cloud resources, or you can define your own. We have a zero trust model here. Zero trust is a model that assumes the worst-case scenario and protects resources with that expectation. It assumes breach at the outset and then verifies each request as though it originated from an uncontrolled network. Defense in depth. Defense in depth protects information and prevents it from being stolen by unauthorized parties by using a series of mechanisms to slow the advance of an attack that aims at acquiring unauthorized access to the data. Defender for Cloud. This is a monitoring tool for security posture management and threat protection. It monitors your cloud and on-premise environments to provide guidance and notifications aimed at strengthening your security posture. It thus helps protect against cyber attacks and streamlines security management. Deployment of Defender for Cloud is easy since it's already natively integrated into Azure. Moving on to cost management and governance tools. A number of factors influence the cost you incur in Azure. The type of resources, the settings for the resource, and the Azure region, for instance, will have an impact on how much a resource costs. As touched upon earlier, these costs are categorized as OpEx. And with Azure, the payment model is the consumption-based or pay-as-you-go model, where you pay for the resources that you use during a billing cycle. The pricing calculator helps you understand potential Azure expenses, and the focus is on the cost of provisioned resources in Azure. It gives you an estimated cost for provisioned resources. The TCO calculator is a slightly different tool from the pricing calculator and is designed to help you compare the costs for running an on-premises infrastructure compared to an Azure cloud infrastructure. The TCO calculator compares the anticipated costs for your current environment with an Azure environment supporting the same infrastructure requirements. Azure Cost Management tool provides the ability to check Azure resource costs, create alerts based on resource spend, and create budgets to automate management of resources. Cost management helps avoid situations if you accidentally provision new resources and you may not be aware of them until it's time for your invoice. Then there are resource tags. Tags are a way to organize resources as your cloud usage grows. Tags provide metadata about resources. This extra information is useful for things like resource management, cost management, operations management, security, governance, and compliance. Talking about governance and compliance, Azure Blueprints help standardize cloud subscription or environment deployments. You can define repeatable settings and policies that are applied as new subscriptions are created. Azure Blueprints also let you deploy new test or dev environments with pre-configured security and compliance settings, so development teams can rapidly build and deploy such environments. Azure Policy. In Azure, you'd want to ensure that your resources stay compliant, and you are alerted if a resource's configuration changes. Azure Policy enables you to create, assign, and manage policies that control or audit your resources. They enforce rules across your resource configurations so that the configurations stay compliant with corporate standards. Resource locks. These prevent resources from accidentally being deleted or updated, depending on the type of the lock. Lastly, the Service Trust Portal. It is a portal that provides access to various content, tools, and other resources about Microsoft security, privacy, and compliance practices. Now let's look at some monitoring tools. Azure Advisor. It evaluates Azure resources and makes recommendations to help you improve reliability, security, and performance, achieve operational excellence, and reduce costs. It helps you save time on cloud optimization. Azure Service Health helps you keep track of Azure, the resources you deployed, and overall status of Azure. Azure Status gives you a broad picture of the status of Azure globally. It informs you of service outages. Service Health provides a narrower view of Azure services and regions, while Resource Health is a more tailored view of your Azure resources. Azure Monitor is a platform for collecting data on your resources, analyzing that data, visualizing the information, and even acting on the results. It can monitor Azure resources and on-premises resources. Within Azure Monitor, we have Azure Log Analytics, which is a tool in the portal to write and run log queries on the data gathered by the Azure Monitor. Azure Monitor alerts are an automated way to stay informed when Azure Monitor detects a threshold being crossed. Depending on your configuration, Azure Monitor alerts can attempt corrective action. Lastly, Application Insights. It is another Azure Monitor feature. It monitors web applications that may be running in Azure on-premises. How would you interact with Azure? And how can you use Azure services? You need tools for interacting with the Azure environment, the subscriptions, resources, and so on. And Azure provides multiple tools for managing your environment. Firstly, the Azure portal. It lets you create, configure, and control all services and resources from a single easy-to-use web-based graphical user interface. Azure PowerShell is a shell with which developers and IT professionals run commandlets. These commands can call the Azure REST API to perform management tasks in Azure. Azure Command Line Interface, or CLI, is similar to Azure PowerShell, with the primary difference being the syntax of commands. While Azure PowerShell uses PowerShell commands, the Azure CLI uses Bash commands. Azure Cloud Shell is a browser-based shell tool that allows you to create, configure, and manage Azure resources using a shell. It supports both PowerShell and CLI. Azure Arc allows you to manage resources such as servers, which may be hosted outside of Azure. Arc is a set of technologies that extends compliance and monitoring and helps manage your cloud environment, whether it's a public, private, hybrid, or a multi-cloud environment. Then we have Azure Resource Manager, or ARM, and ARM templates. ARM is the deployment and management service in Azure. It provides a management layer enabling you to create, update, and delete resources in Azure. Anytime you do anything with your Azure resources, ARM is involved. Creating and using Azure services. To do this, you need an Azure subscription. You can get started with Azure accounts. An Azure free account, you can begin exploring what Azure has to offer by signing up for one. This includes access to 20 Azure products free for 12 months, along with access to additional products that are always free and a $200 credit to spend during your first 30 days. For more information on signing up for a free Azure account, you can head to azure.microsoft.com/free. Azure Free Student Account. This offer includes free access to certain Azure services for 12 months, a credit to use in the first 12 months, free access to certain software developer tools. The Azure Free Student Account is an offer for students that gives $100 credit and free developer tools. Also, you can sign up without a credit card. You can purchase Azure directly from Microsoft by signing up on the Azure website or through a Microsoft representative. Cloud Solution Provider Partners. You can purchase Azure Access through a Microsoft partner. Cloud Solution Provider Partners offer a range of complete managed cloud solutions for Azure. Now that we've looked at Azure, I'm going to shift gears here a little bit. Because while we are at this getting to know various aspects of Azure, I would like to introduce you to Intune, which is part of Azure. Intune is a cloud-based endpoint management solution. It extends on-premise functionality of Configuration Manager. Intune manages user access and simplifies app and device management across devices, including mobile devices, desktops, laptops, and virtual machines. Microsoft recently announced rebranding for Intune and its growth into a family of endpoint management products. Intune falls under the security umbrella, since it enables you to securely manage organizational endpoints. With that introduction, I would encourage you to explore Intune and explore endpoint management, as it is an in-demand skill set in current times. So, to finish up here, if you are new to the cloud or just getting to know what cloud is all about, I hope my session was of help. Exploring and learning Azure skills should be beneficial to anyone in IT. Also, Intune and endpoint management is a great segue for a booming IT career. So go explore Azure, explore Intune, keep up with the ever-evolving technologies. Taking it further from this session, you could study for the official certification from Microsoft, the AZ900, which is the Azure Fundamentals exam. Microsoft Learn has great content on the Azure Fundamentals Learning Path series to help you prepare for the exam. Alright, so that puts a wrap on my session. I believe you got a good head start into Azure with the walkthrough in this session. I hope you enjoyed the session as much as I have putting it together. I wish you the best of luck on your cloud journey. Thank you. Happy learning and happy holidays.